Hello, Math 126 fans. I want to say a few things about Section 14.7 because a lot of things come together here. And in my mind, there's three main types of questions. And so I just wanted to highlight what they are. I'm going to start by showing you the test prep you're actually going to do Thursday. But I think this is good to just sort of look through the problem. So you can play around with this. Anybody else watching this video can go to my materials page, click on test prep 14.7. You can see it as well. And it's a collection of old exam questions that I've written. So one big thing in this section that we're doing is finding and classifying critical points. Now, that's just a general tool for analyzing a function, meaning where are the bumps, where are the hills and valleys, where are the local max, where are the local min, where are the saddle points. So you do want to be able to do that before you leave our course. So that's what these questions are. And you can easily find lots of these on old exams. There's a little component of algebra where first you compute both partial derivatives, you set them both equal to 0, and then you're solving a system of equations. And so I will talk a lot about this in class, some common misconceptions. I'm sure I'll make a supplemental video on that. But that's just this algebra skill. At the end of this, you'll have points. Those are called the critical points. And then you classify them, and that's the second derivative test. That's fairly straightforward. It does require, a good chunk of 3/4 of a page, half a page to do. But it's a skill you can practice. So that's number one. And I have a couple, what I tried to do is have an example of all these. So here's more of this. Find and classify the critical points. Find and classify the critical points. Very likely you're going to have something like that coming on the second exam. You got to know your partial derivatives well. You got to be able to solve. You have to have good routines to check and classify. But it's fairly straightforward. That's one type of question. Another type of question would be what we call a global max and min. Now, those are the ones that students are scared of the most, in my experience, but they're the ones that are very formulaic. And part of the reason I think people get stuck here is because they don't remember their global max and min methods from Calculus 1. So I think I'll probably make something to review that. But it's this basic idea of if you want to know the global max and min, you're going to plug all your points back into your original function and see which is biggest. So the whole technique is to try to find which points we need to plug in, because you start with an infinite number of them. You can't plug them all in. So you try to reduce the number of points. So if you forgot this in one variable calculus, in that situation, the answer is always either a critical number or an endpoint. In this situation, it's either a critical point or a point on the boundary. And the boundary is the interesting piece of this. And so we'll talk about this. You basically go one by one through the boundary. So like the second question here, because the boundary has two sides, a half circle and a line, you're going to have to do a problem for the half circle and a problem for the line. So ultimately there are three problems to do in this one problem. But if you know that going in, and I'll teach you this well, you go, okay, I need to do the line, I need to do the half circle, and then I need to talk about the inside. The inside's actually the easy part. Okay, and the last thing you have is applied problem. Now, we don't do quite as many applied problems as you do in Calculus 1, but I like these applied problems. In some sense, they're easier in the sense that you can check your answer for whether it's reasonable. And you can run experiments and examples. And I have a clear way to approach these. And there's one main question, which is what are you trying to optimize? So we'll talk about this in class. It doesn't matter what the rest of the story says. At the bottom of the story, it says we're going to minimize the total material used. That's really all you need, and that tells you how to do the whole problem. Your job is to find a two-variable function for the material used, for the surface area. The surface area is what you're going to take the partial derivatives of. The surface area is what you're going to find the critical points for. All the rest of the information is to help you find a two-variable function for the surface area. That's it. If you take the derivative of volume or something else, then you're missing that key idea. So we'll talk about this. We label, we find that two variable function. There's always a constraint, because if there's not a constraint, the question doesn't make sense. If there was no constraint, you just wouldn't build it. Okay, so that's what these are. So I'll talk about those a little bit. Those are kind of more fun. But the two kind of mechanical questions are the global max and min, the local max min. So that's a little flavor of what's coming. It's kind of nice to see the problems that are coming. If you want kind of a taste of this, I have really like this review sheet that I made years ago that says, here's what you did in Calculus 1. Here's what we're going to do in Calculus 3. Notice how they're the same. Notice how they're different. I'm going to hand this out in class. I like this review sheet as well, where I sort of recap. You need to eventually put it in your own words, but we're going to learn to find critical points. We're going to learn to classify them with the second derivative test. We're going to do absolute or global max-min. I use those words interchangeably, and I sort of lay out. It sounds like a lot when I say it here. It's more about this idea. And then we will do a little bit of applied max and min. So I just wanted to say that to sort of go, this is the interesting part of chapter 14 for us, because we don't go into some of the other pieces. And so if you kind of know that going in, that there's these three main types of questions, they all start with finding the partial derivatives. They basically all involve setting them equal to 0 and solving. So that's the overarching theme. It's just we're making different conclusions from that. As always, you can find more stuff on my page. You can see old lecture notes where I have lots of examples. Okay, just wanted to give you a lay of the land.